Hello everyone, this is Vardhaman and welcome back. The topic for today's video will be asymptotic notations. Asymptotic notation are mathematical tools used to analyze the performance of algorithm by analyzing how their efficiency changes as the input size grow. By using asymptotic notation such as big O, big omega, big theta, we can categorize algorithm based on their worst case, best case or average case time or space complexity, providing the values inside of their efficiency. So we will look at all three notation in detail. Let's see all three notation one by one. So first is big O notation. Let fn and gn be two non-negative function. We can say fn is equal to big O of gn if and only if fn is smaller than or equal to c of gn. For all n should be greater than n naught, where c and n naught are two positive constant, where c is greater than 0 and n naught is greater than or equal to 0. So this is just the book definition and probably you may have not understood what that meant. So we will be learning big O of notation in more detail with the help of some example. Let's look at example. So we have our fn which is equal to n plus 10 and we have gn which is equal to n, and we have to check if fn is big O of g of n. So to prove it, we have to prove that f of n is smaller than or equal to c into gn. So we can replace the value here. F of n is n plus 10 and g of n is n. Now we have to choose a value of c and n naught such that if we take any value of n greater than n naught, we should satisfy the condition. So we have to satisfy this condition if we take any value greater than n naught. So let's substitute the value. So this is our fn and this is our gn. So we will take the value of c as 1 and n naught also 1. So fn will become 1 plus 10 and gn will become 1 into 1, which is 11 and 1. So 11 is greater than 1. So we are not satisfying this condition. Now we can take value of c as 2 and value of n naught as 10. So here if we see, fn will become 10 plus 10 and gn will become 2 into 10. So in this case this will be equal. So this will become 20 and g of n will also become 20. So here we can say these two fn and gn are now equal. Now if we take any value of n naught and we keep c constant, we can see it will always satisfy the condition. So let's see. Let's keep the value of c as constant, which is 2, and n naught we can take 20. So here it will become 20 plus 10 and c into gn will become 2 into 20. So fn is 30 and c dot gn is 40. Let's take one more example. We can keep c as constant 2 and we keep n naught as 30. Now here it is 30 plus 10 and it will become 20 into 2 into 30. So this is 40 and this is 60. So this condition will always satisfy. F of n will always be smaller than or equal to c into gn. So we can say that f of n is big O of gn, which is n plus 10 is big O of n. So here the value of c we got is 2 and n naught is 10. If we increase the value of n after 10 and keeping the c constant, so it will always satisfy the condition. Now let's understand bigger notation with the help of a graph. So on y-axis we have fn and gn, and the x-axis represent n. We can say f of n is bigger of gn if and only if fn is smaller than or equal to c into gn. For all value of n should be greater than n naught, where c and n are two positive constant. We can check in the graph that up to certain point, the value of fn and c into gn are not equal. They do not have any relation. Sometimes fn is bigger and sometimes g of n is bigger. But from a certain point, which is n naught, you can see c of gn is always greater than or equal to fn. So it will be greater than or equal to. So at n naught it is equal to, and after n naught it is always greater than. If we take any value of n, so if we increase the value of n, like if we take the value n naught plus 1, n naught plus 2, so this condition should always satisfy. C of gn should always be greater than fn. In that case we can say f of n is bigger of c gn. And if we check our previous example, we found out such value. So c is equal to 2 and n naught is equal to 10. So we found these two values, and if we take any value greater than n naught, which is 10, so we will find out that we will always satisfy this condition. So we have tried few examples, like for 10 we found out it is equal, and if we keep on increasing the value, we have also checked for 20, so we got the value of c dot gn as 40, whereas fn is 30. For 30, c dot gn is 60 and fn is 40. So we are satisfying this condition every time. So in that case we can say f of n bigger of gn. Let's do few questions. So we have our fn, which is equal to n square plus n plus 10, and we have our gn equal to n square. We have to check if fn is bigger of gn. So we have to prove that fn is smaller than or equal to c or to gn. So basically we have to find two values, which is c and n naught. So let's check. So our fn is n square plus n plus 10, and our gn is n square. So we are looking for c into gn. So let's take the first value of c equal to 1 and n not equal to 1, which will become 1 plus 1 plus 10, and this will be 1. So 12 is not smaller than or equal to 1, so we fail for c equal to 1 and not equal to 1. Let's take some large value. So it's not like that we have to take 1 by 1 each value, like we have to take c equal to 2 and n not equal to 2. We can take any large value also. So let's try for 3 if 3 works, and we also not have to take the values equal every time. Now let's try for 3 and 3. So here n square will be 3 square plus 3 plus 10, and this side we will get 3 into 3 square, which is 9 plus 3 plus 10. Now this will become 3 into 9. This side we can write 10 plus 9 is 19, 19 plus 3 is 22, and 3 into 9 is 27. So here we can see for c equal to 3 and n not equal to 3, f of n is smaller than or equal to gn. So this is smaller than. So we found a value. So we found a value of c equal to 3 and I not equal to 3. So after this point, if we check for any bigger value, let's check for 4 also. So it will be 4 square plus 4 plus 10, and it will be 3 into 4 square. 4 square is 16 plus 4 plus 10, this will be 20 plus 10 30, and here it will be 3 into 16, so it will be 48. So here also f of n is smaller than c of gn. So after n not equal to 3, if we take any value of n, then we can see this condition will always satisfy. So we can say here f of n is bigger of gn. Let's see the last question. We have fn equal to n square and gn equal to n. So we have to check if fn is bigger of gn. Let's see. So condition we have to prove is fn should be smaller than or equal to c into gn, where c and not are constant. Keep this point in mind. So we have fn equal to n square and we have gn equal to n, so c dot gn. So now think about a value which will satisfy the condition. This should be smaller than or equal to. So the only condition coming to mind is if we keep the value of c as n, right? If the value of c of n, then this can become n square and this will be equal to n square as well. And if we take any value of c, like we take the value of c as 100, so fn will become n square and c of gn will become 100 into n. So this is not satisfying the condition, this will be greater than. So the only condition that will satisfy will be if we keep the value of c equal to n. So if we keep the value of c equal to n, then it will become n square both sides and this will satisfy the condition. But here we have already talked c and n naught should be constant. So the value of n should be constant and it cannot be a variable. So this is not possible and it will not satisfy any condition. So if we take the value of c anything, it will not satisfy the condition until we take the value of c as n. So we can say here fn is not equal to big of gn. So this is the one question in which it is not satisfying the condition and it is not equal to big of gn.